Kia ora, Year 11 and 12. Here's a trig question for Kieran from the June 2014 paper. It's quite a nice question that I thought was worth going over in a video. So we're told that we've got a reflex angle and it's theta, such that cos of theta is equal to k, and k is a positive number between 0 and 1. We have to find an expression in terms of k for sine of theta and then tan of theta. And then we have to explain why sine of 2 theta is negative for k between 0 and 1. So there are a couple of things to think about when you're doing this question. The first thing that we want to think about is, what does it mean to have a reflex angle? So a reflex angle is between 180 degrees and 360 degrees, right? But in this question, we're told that cos of theta is a number and cos of theta is a positive number. So hopefully at this point you're thinking it might be worth drawing the cosine curve and having a look at where it's positive and where it's negative. And from there we're going to use our only trig identity that we really know in A level, in AS, which is sine squared theta plus cos squared theta is equal to 1. So let's do that on a new page. So here's the cosine curve. It starts at 1 and it goes like this. So key points in here. This point here is, whoops, wrong pen, 90 degrees. This is 180. This is 270. And this gets me back to 360. So we know that cos of theta is equal to k, and k is positive. So that means we can pin down where we are. We're not between 180 and 270. We're in this range here. So we know that theta is between 270 and 360. Okay, so we're in here. Now what can I say now? I need to find an expression for sine of theta. I know that cos squared theta plus sine squared theta is equal to 1. So k squared plus sine squared theta is equal to 1. That leaves me with an expression for sine squared theta. Sine squared theta is 1 minus k squared. So sine of theta is the square root of that, but it could be the positive or the negative square root. Right? Remember, when we just write this, we mean, by definition, the positive square root. Right? Now, in a couple of countries in the world where it's not like that, but in New Zealand and the UK and the US, that's how we do it. So that means that we have to choose which of those is the right answer for sine of theta. Is it root 1 minus k squared, or is it negative root 1 minus k squared? So to figure that out, we have to go back to the graph. Well, I think that's the easiest way to think about it. So my cosine curve is drawn there, but now I'm going to draw in my sine curve. So the sine curve looks like this, right? And we know that theta is between 270 and 360. So sine of theta is negative for those values, right? So we can see down here, we want that part of the sine curve. So that means that my answer to that problem is that sine of theta is equal to negative root 1 minus k squared. What about tan theta? Well, that's pretty easy. Tan of theta is equal to sine of theta over cosine of theta, which is just this. So that's that one done. Now the last part of the question asks us to show something. Oops, where's it gone? Here we are. Okay, explain why sine of 2 theta is negative for k between 0 and 1. There are different ways to think about this problem, but this is what I found the easiest. We know that theta is between 270 and 360. That means that 2 theta is between 540 degrees and 720 degrees. So what do we know about sine of 2 theta for those values? Well, if you think about the sine curve, just thinking about the simple sine of theta curve, it's got a period of 360 degrees, right? So working with these two values is like working with being between 180 and 360, right? I can just shift everything back from being up here. Or I could just draw this in, right? So here we are, we've got values between 540 and 720. So you can see from the graph that sine of theta for theta between 540 and 720 is negative as required. Okay, so 2 theta is between these values, and then I take the sine of that number. So that's the first part of the problem done, and that's the bit that Kieran was asking about. But I thought I'd chuck in another trig question as well, just to make the video slightly more interesting. We have to prove this identity. So we start off, as usual, by saying left-hand side, we've got 1 over cos theta minus cos theta over 1 plus sine theta. Right, what do I do? Well, I'm subtracting fractions, so I get a common denominator. That's usually going to help. I bet you've all turned off the video now because you can do this part. Okay, so the top line has got sine and cosine in it. I can easily switch one of those things to match the other, and the one that's easiest to switch is the cosine squared, especially because with what we've learned so far in AS, we don't really have many choices. It gets a bit more fun when you've got lots more identities. You'll get to that in A level next year. So here we go, we've got 1 minus sine squared theta. And you probably can see where we're going. We're going to get a common factor in here that we can simplify. So in the numerator, I've got sine theta plus sine squared theta. So remember that it's a show that question, so don't skip too many of these steps. So here we've got sine theta into 1 plus sine theta over cos theta. And that gives me tan of theta. And that's the right-hand side as required. The last part of the problem, as usual, asks me to go on and solve, oops, wrong pen, solve this equation. And we're looking for values between 0 and 360 degrees. So how can I do that? Well, that problem just becomes very, very easy because of the proof that we've just done. So we have 1 over cos theta minus cos theta over 1 plus sine theta plus 2 is equal to 0. But we know that that first bit simplifies to tan of theta. So we're solving tan of theta is negative 2. Theta is tan inverse of negative 2. Chucking that into your calculator is going to give you a value of negative 63.4 degrees. So that's not in the range that we want. So the values that we want are between 0 and 360. As usual, draw that graph. There's your line. Oops, no, I want a different colour for that line. There we are. We've got 2 values, 1 value here and 1 value here. With the tan function, using symmetry is super easy. We just have to add on 180 to that first value. So theta is equal to 106.6 degrees. And then we add on another 180 and we get 296.6 degrees. Thanks for watching. Send me an email if you've got any last minute questions that you want me to have a look at.